Hello, and welcome to the Age of Gaming. In the next two videos, we're going to start discussing the PIA ports, and I'm going to break this down very simply for you and make this just easy to work with. Basically, your PIA chip, or the 6530 RAID chip, which stands for RAM, I/O, and timer on the KIM-1 here, is two 8-bit I/O ports. You got port A and you have port B. Port A has two registers, which is the port A data register and the port A data directional register. And port B has the same. It has a port B data register as well as a port B data directional register, which you use to tell the port whether it's going to be used as an input or an output. And you can specify that for each bit individually. We're not going to do that. We're just going to set, port A up as inputs and port B up as outputs in this one. So let's get started and take a look at your input outputs and see what we can do with them. All right, turn our KIM-1 on. And the first thing with the KIM-1, you always want to go to 17FA and enter your IRQ vectors, which is 001C and 001C again. Okay, now we're going to go straight to the port A data register here, which is at 1700. You can see we don't have anything in there. But if we wanted to set it up for an input or output, we have to go to 1701, which is currently set up as 00, and 00 equals all 8 bits are set up as inputs, which is great because that's what we want. We have all these dip switches set up to be inputs. Now to see the output register, you go up one more to 1702, and you can see we have some data in there and our LEDs are all lit up. Well, that's because we haven't set up the B port to be an output register yet. So to set that up, you go to the data port, or the port B data directional register, which is at 1703, and you can see it's also set up as all inputs. And that's why these lines are all floating high and all the LEDs are lit. So let's change that to make it an output port. So we're data and FF, and you can see all the LEDs turned off. Now let's jump back to our port A data register and see what happens when we flip these switches. You see a 1 there, a 2 there, 4 there, and an 8 there. And if you went on, you'd have a 1, 0, 2, 0, 4, 0, and an 8, 0, but we're only worried for the first 4 right now. Now, if we want to see the port B, the output port, just go over here to 1702, and you can see it's 00, none of the lights are lit up. And all you have to do is store something in 1702, and it'll light up, specifically a 1, 2, 4, or 8. So let's enter a 1, and you can see the first LED came on, a 02, a 04, and a 08. Now this is a good thing to do when you first set up your breadboard and your experiment, to make sure everything is working correctly and that your ports are doing the right things, that they're set up correctly, that everything's working before you start, a complex program. And if your circuit isn't set up right, it's not going to work anyway. Anyhow, so let's see how we might be able to install some simple code to do all of these things for us. So address 0200, I'm going to write a very simple program that lights up each one of these LEDs one at a time. And it's very simple. I only need 2 commands. I'm going to use an LDA load accumulator with either a 1, 2, 4, or 8, and then store that at our port B data register at 1702. So first, before we get started, 1702, and let's clear that out. All right, now we can go to address 0200 and start writing a simple program. So the first thing we're going to do is we're going to load A with a 01, and then store that at 02 plus 17, or 1702. Then we're going to do the same thing, load A with a 02, and store that at 02 plus 17, which is our port B data register. And then we're going to do the same thing, load A with a 04, store that at 02.17, and then finally load A with a 08 and store that at 02.17, and then for good measure I'm going to do a jump back to 0002 or 200. Let's go back to address 0200 and walk through this again. Load A with a 01, store it at our port B data register. Load A with a 02, store that at the port B data register, and then load A with a 04, store that at 1702, which is our port B data register. And finally load A with a 08 and store that again at 1702. And then jump back to 002. So that looks like it's good. So let's go to address 0200. I'm going to put this in single step mode. And the first command is just load A with a 01 and store that in our port B data register, which is currently configured as an output port. So it should light up the first LED. And there you go. The next command is load A with a 02 and store that at port B, which is address 1702. Load A with a 04, store that in our output port. Load A with a 08 and store that in the port B data register. And then jump back to the beginning, and you can see we wrote a little code that the computer can use to access our little breadboard project here. All right, now let's write some code. Oh, wait, address 1702, let's clear that out. Address 0300, we're going to write some code now that utilizes the port A inputs, and we'll put the correct number out here on our output. So basically what we're going to have to do, instead of loading A with a 1, 2, 4, or 8, we're going to load A with the entire contents of the A port register here, A port A data register. So whichever switch we have, it should show up here on our output because we'll store it at 1702. Once we read it in here, compare to find out which one it is, and then we'll store that onto port B and show up on our LEDs. So let's get started over here. Data, first command, instead of an A9, we're going to use an AD, which is load A. But this time we're going to load it with a memory address 0017, which is our port A. Next thing we're going to do is we're going to compare that to 01, and we're going to branch if not equal down 3 spaces. If it is equal, we're going to store that in our port B data register. Then we're going to compare it again to 02, branch if not equal down 3 spaces. And if it is equal, we'll store that in 02.17. Then we'll do a compare to 04. That's not equal. Branch if not equal, down 3 spaces. If it is equal, we'll store that in our port B data direction. And then finally, we're going to compare to 08, branch if not equal, down 03, or store it in 02 plus 17. Then we'll do our jump back to 00, 03. Address 0300. Now let's see if we have that all set up. So we're loading A with our port A inputs. Compare that to 01, branch if not equal, down to the next one. If it is equal, we'll store that in our port B data register at 1702. Then we'll compare it to 02, and branch if not equal, down 3 spaces, or store that in our port B data register at 1702. Compare it to 04, branch if not equal, or if it is equal, store it at 1702. And the last one, compare to 08. If not equal, branch down 3 spaces. If it is, then store it in our port B data register. Oop, that number is wrong there. That's why we go through this. And loop back. All right, that looks good. Address 0300. I'm going to put it in run mode because nothing's going to happen until I flip a switch. Okay, and press go. Now let's see what happens when we move the first switch. Oh, there you go. And if we move the second switch, hopefully you can see this. We move the third switch. And finally the fourth switch. There you go. So our inputs are getting loaded into port B and displaying on our outputs. And that's all there is to it. It's a very simple process. Programming is very easy. You dump something into your output register and it will show up on whatever you have built on your outputs. Okay, well, I hope you learned something. I hope you're inspired to do your own little project. It is very simple to work with your PIA chips and your computers, so have at it and have a great day.